Ahead and get started. It's my pleasure to welcome you to the electric fencing workshop today. And we're not going to be a huge group, so we're just about right for the hands-on portion in the field. So everybody will get a chance to try some reels and some posts and some fault finders and so forth. And before we get started, I'd like to introduce my co-workers for this workshop. I've got right here Jeremy McGill. Jeremy is from Gallagher, and we've been doing electric fencing workshops since I came to Kentucky in 2007, I guess. No, 2017 was our first one that we did. And then our first speaker is going to be Morgan Hayes. And Morgan Hayes is an engineer in our ag engineering department on campus. And she has an interest in fencing systems and livestock housing systems. And she's also a producer, so she uses electric fencing on her farm. And she'll tell you a little bit more about that as she goes through. And then I'd like to recognize my technician, Brittany. Stand up, Brittany, in the back. Brittany's going to be helping us outside with the electric fencing hands-on portion. So these are some really unique schools because it really incorporates a lot of hands-on learning, and people tend to learn the best when they actually get to try something. So you're going to get to try some electric fencing. I hope nobody gets shocked, but if you do, it's a safe shock, and it won't hurt you too bad. So with that, I think we'll go ahead and get started. And Morgan is going to talk a little bit about fencing and electric fencing and a little bit on the theory behind electric fencing. So with that, I'm going to turn it over to Morgan. Oh, do you want to?
For just a second.
Okay.
Yeah. So this session is being recorded, just so you all know. And then we do also have conference session feedback cards, and I'm going to pass out to you all. If you please fill them out and then give them back to me. And like he was saying, this is a two-part session. The second part, the outside demonstration, will start at 4:30 in case there's people from other sessions who want to join. So even if we end this session early, we'll still start the demonstration outside at 4:30.
Thank you. Okay, so let's go ahead and get started here. I just want to touch on what we're talking about with electric fencing today is a lot of work on what's probably more likely some temporary fencing testing, but both permanent and temporary fencing can be done with electric. Permanent fencing usually doesn't require us to set down or take up the fence. It's more secure. It's what we would typically use on our perimeters of our farm to contain animals. There's lots of different types of permanent fencing out there, so lots of different looks on permanent fencing. We'll talk about those different looks, keeping in mind that those different looks a lot of times use wood posts, and treated wood posts are a no-no for organic operations. The problem with a permanent fence system is that it's fairly expensive. There is labor associated with permanent fencing because we have to take down and manage the ground underneath that fence, and we can't remove it and then mow. So it makes mechanical destruction a little bit difficult. And if we don't like our layout, we can't change it very easily. That's a huge problem. The temporary fencing systems are much more flexible. They're far less expensive. We can remove them to mow, which is nice. The problems with it are, of course, that it's not nearly as secure typically. Animals do get through them. And it requires a lot of labor to set down and take up that fencing. And a lot of times that means that there's redundancy. So not only do you have to have the materials that you're using to run your fence, but materials to set up another line of fence somewhere else on the farm at the same time, or a secondary fence as an extra boundary in case they make it through the first fence so that they don't make it through everything that you own all at once. And if I was to describe the perfect fence to you, these are the characteristics I would be looking for in my fence. I'd want it to be super visible so my animals knew where it was. I'd want it to be tall enough that they can't get over it, solid and strong so they can't get through it, inexpensive, wouldn't that be nice? I want it to be low maintenance. I don't want to do any work ever again. It's one of my goals in farming. It's never, ever going to come true, but it's a goal. And I want it to last for my life if I can. I don't want to have to redo a fence. I tell people all the time, I'm currently fencing my farms. We've put in miles of fence in the last 5 years, and I'm hoping the next person to put in the miles of fence is my child, who's currently 2. I'm hoping it's not me again. I don't know that that's going to happen, though. But what I have to do is I have to be realistic that not one type of fence is going to achieve all of these things to the best. And so I'm going to have to prioritize certain areas. And one of the things that I think a lot of people have to use in their consideration is the expense. And that's one reason that I want to just touch on the electric fencing here. I'm going to do a little bit about the pricing on these systems, and you can see how inexpensive electric can be to some of the other options that are out there. The typical fences we see here in central Kentucky are wood plank, woven wire, a fixed knot high tensile, which looks exactly like a woven wire, an electrified high tensile, and a barbed wire. By the way, a barbed wire is not an electrified fence, and it should never be an electrified fence. That's just a general statement of fact there for you guys. And all of these costs that I've run here are from a calculator from Virginia Tech, which is really nice for permanent fencing. All of it is done with wood posts in it, and I prefaced this earlier that I understand from an organic standpoint that you might not be putting treated wood posts in the ground. If you're not buying treated wood posts and you're putting wood posts in the ground, you're going to have to find a wood that's fairly resistant to deterioration, a locust, an Osage orange, cedar possibly, and that will change the cost structure because they're a little bit more difficult to find and or they're more labor intensive because you have to go get them off of your own farm. But all of it assumes this is about 1,000 foot of fencing, putting in my braces that I need for the structure of the fence, that I have line posts and end posts, and they're a little bit larger on my ends, and that I'm actually going to get them in the ground the way I need them. They have to be in the ground about 2.5 to 3 feet down to make sure they're below the frost line so they don't heave and come out of my fence line. And it's going to take time and energy to do that, so I have to account for that as well in my cost. This is not the cost you're going to pay someone else to build your fence. This is if you were to account for your own time and energy and equipment being used. And so it gives you at least a rough idea on the comparison of the different types of fencing from a cost perspective. For a 4-board plank fence, I've run these numbers in the last year, and we see a number a little over $6 a foot. And that's merely for the materials and your labor at a very low cost. That is not what you'd get charged if you were to get that job hired out. And it also doesn't include painting a board fence. But some people still like the board fence. The board fence is extremely visible. It's aesthetically pleasing, and depending on what your operation is doing and how you're selling or managing sales of a product off of a farm, that might be something that you still want to consider for part of your frontage on the road. It's not something I'm considering on my farm because I hate weed eating, and I hate painting wood fence. Woven wire is the standard fence that we've always used on our perimeters. It's a nice material. It handles well if someone doesn't actually maintain the fence line and trees and shrubs start growing up into the fence. We do 2 types of fencing schools. Today we're talking specifically about electric fencing, but we do a secondary fencing school where we do a lot of work on woven and fixed knot high tensile, and we talk in more detail about the difference between the two. But a woven wire fence, because of the style of the metal in that fence, requires posts very regularly every 12 feet. It needs those posts there to hold that fence up, otherwise it sags down. That is one of the challenges with woven wire fences, is that they stretch over time and they sag. And so that fence is a little over $4 a foot. The fixed knot high tensile looks very similar to a standard woven wire fence. The major difference is it has a different carbon amount in the steel in the fence wire, and that means that it doesn't stretch as much. It has about 1% stretch as opposed to the 10% that you'd see on a standard woven wire fence, and it doesn't sag nearly as much, and therefore we can space out our posts with a fixed knot high tensile, and it drops this whole cost because, one, we don't have to put in as many posts in the ground, and then secondarily, we have a material cost here. We have a little bit less steel in it typically, and so it comes out a little bit under $3. Not a bad price. This one, anywhere from 15 to 20 to 25 feet. It depends on the ground. As long as I have very flat ground, I can stretch it out into the 20, 25 foot range. If I have a lot of undulations in the ground, then I need to follow the ground so that the wire follows. Yes?
Repeat my question. You said 2.5 to 3 feet cross line, and I thought the cross line was 18 inches. And then you sort of mentioned fixed knot.
So the first question was about the frost line, why I want to be at least 24, but ideally I want to be closer to 30 inches deep. The frost line is, in theory, around here supposed to be about 16 to 18 inches. What ends up happening, though, is that a lot of times if we're low enough on the post where that freeze thaw is occurring, it starts to work that post up. We want enough of that post set in the ground below that frost line that it's anchored, that it can't work its way up. Does that make sense? We need enough percentage of the post in ground contact where that ground is the soil is adhering to the bottom of that post and it's not releasing it, that it'll hold it stable. Does that make sense? Certainly if people, I know that there's long conversations about using concrete on posts, but certainly if you were using concrete on a post, it would definitely need to be below that point, because we definitely don't want anything to help it work its way up in that top portion of the area. Although I think generally most people don't recommend concrete because it can hold water up against the posts in general. So the second part of the question was the difference in the style of the knot on the fixed knot versus a woven fence. On a fixed knot fence, there are horizontal lines that are continuous strands of wire running the length of your fence. And on a fixed knot fence, the way the knot is done, there's actually a horizontal stay that's also continuous. So the knot is wrapped around each vertical wire and horizontal wire as they cross. With a woven wire fence, each horizontal stay is wrapped at each horizontal wire runs continuous. Each vertical stay is wrapped on the horizontal wires. So each section on a standard woven wire fence is independent, and that's why they can sort of sag down like that. It's the reason that a fixed knot high tensile fence will pop up when it's pulled under tension, because those vertical wires will help keep it vertical, because it's a continuous strand of wire that runs from the bottom of the fence all the way up to the top. It's just the style of the knotting. It's a specialized piece of equipment that they've developed, and it's just the way that the process works.
Morgan, can you remind them if they're interested in fixed knot high tensile fence that we'll have 2 fencing schools in April, this April?
Yeah, we have 2 fencing schools in April. One of them is in Madison County?
Yeah, Richmond.
And then one of them is down near Bowling Green. And thank you, in Albany. Yes? What's that? It's at the extension office, yeah, and it'll be listed on the Kentucky Forage's website, so there'll be a link there to register for it if that's something that is of interest, is to look at that type of fencing. But the fixed knot is really a nice option for a perimeter fence if we're looking for a more permanent option. The 5-strand high tensile fence, electrified, and I say electrified because high tensile fence doesn't really work well without electricity associated with it. Animals can get through it. The benefit of it is that as long as it's electrified, we don't need a lot of posts in this fence either. This fence is very forgiving to similar spacings or even a little bit further than what we did with the fixed knot. high tensile. We can still stretch our post spacings out to 20 or 25 feet pretty comfortably, as long as the ground isn't too wild. And what ends up happening is, one, the wire is very cheap and we only need 5 strands of it, and it's pennies per foot to run that wire. And then those posts we can space out and potentially use something else in between. And if we're not using wood posts in our line, we have to use a different type of post, but I'm sure Jeremy can talk a little bit about some of the other options that are out there for electrified fencing that are very practical. And we're coming out somewhere in that $2 a foot range, which is a pretty cost-effective way to build a fence in today's dollars and cents. And then last but not least here, this is the 4-strand barbed wire fence. It's still a high tensile barbed wire. That's typically what we can purchase these days. This barbed wire fence, though, is interesting. A lot of people think this is the cheapest type of fence on the market, and you can see here that because I need posts every 12 feet, similar to the woven wire fence, our costs go way back up because it takes a lot of energy to put all those posts in the ground and attach that barbed wire to all of those. And if I had to do this kind of labor, I would double my rate because I hate barbed wire. But even if you didn't do that, you're still going to end up with a pretty high cost just because there's so many posts and all the effort to get those in the ground and get that barbed wire attached. And so it ends up actually costing out very similar, slightly less, but very similar to a fixed, not high tensile fence, which is interesting. I could have almost a woven material, or I could have 4 strands of barb for almost the same money per foot, which is pretty wild to think about. It's something that's been pretty consistent over the last couple of years that we've seen that sort of cost comparison, and it's sort of unexpected. The other thing to note is that, the type of post you use are going to play a major role in how much it costs to put in a fence. So you want to be really conscious of the type of post you put in because, like I said before, I'm only building the fence once in my lifetime, I'm hoping. So I'm going to do everything I can to make that a cost-effective decision. So I want to pick materials that are going to hold up. Certainly, I would never choose a light-duty fiberglass post. That just wouldn't be something that I would put into a fence line just because I don't want to have to replace them every couple of years. Inside the electric fencing system itself, there's a bunch of different parts. There's chargers, wire, a grounding system, insulators, and we need all of those to make the electric fence work. There's a lot of different styles of chargers or energizers out there on the market. There's solar ones, there's battery-operated ones, there's ones that plug into the wall. Jeremy, you're going to talk about these quite a bit. I'll let you do that. Also, there's all different types of wires out there. There's poly wires, there's high tensile wire. All of them have different conductivities associated with them, and we'll touch on what that means. But you want to pick the component that's going to make sense on your operation. And the most important part of this fencing system is a ground. If we don't have a good grounding system, we can build an awful lot of fence that does absolutely nothing. We have to have a grounding system in order for a shock to occur, because we have to have a difference between a positive and a negative charge. And if we don't have a ground, we don't have a base to create a charge against. And so it's really important that we put in a good grounding system with ground rods that are appropriately sized for the amount of energy we're pushing out on our fence, so that we can get a true circuit if we need it when something touches that fence. And last but not least, we want to pick good insulators, because the last thing we want to do is build this beautiful fence and then all of the energy just keeps leaking out of the system, because that makes the whole system very frustrating. And that's when people give up on it, right, Jeremy? I haven't given up yet. I keep searching for faults on some of my lines. The way electric fencing works is that charger or that energizer is going to push energy out in a pulse. So it's essentially going to throw out energy continuously in very short bursts of time. Look at that. You can almost see it in this room. And then when that animal runs up on that fence, it's going to touch it. And what's going to end up happening is that when it pulses there and that animal touches it, it's going to start taking that pulse through the animal because the animal is conductive, and it's going to hit that ground underneath that animal, and that charge is going to come back to that ground system, and we're going to have a full circuit. And that's what's actually going to create the shock that the animal feels. Or you. I mean, I guess what you feel too when you hit it. I'm going to do a few definitions here just to kind of get you familiar with the terminology. But energy is the amount or ability to complete a particular amount of work. For electrical energy, we're essentially moving electrons or little amounts of energy that typically would go around a cell, right? You remember anyone from a proton, a neutron, and electron from any of their other high school classes there. And it flows in a current. So those flow around that circuit, and that electron has to move some distance for work to be occurring. So essentially we're trying to move a particle, and that is the energy that's occurring in a fence like this. And these electrons, a lot of people think they move through the wire, but they don't. They actually move on the surface of the wire. So what ends up happening is in a high tensile fence, the wire you typically see on a perimeter or on a more permanent system, you have this huge surface area over a continuous piece of steel, and those electrons can move anywhere they want to around that outside surface area. The polywire systems that we use for a lot of our interior fences have tiny little strands of wire in them that are metal, and those electrons have to move on those. Hang on, let me go back. I can't even get a red light up there. You have to move around those little black circles up there around each of those individual metal wires. And what you end up happening is you have this huge area on that high tensile wire that allows those electrons to move, but on that poly wire, a lot less area associated, making it harder for those electrons to travel down the fence. Joules are what we use to describe a unit of electrical energy, and the work done is stored in the flow of electrons as energy. So essentially what this means is that what joules is telling us is how much capacity we have to do that work. So 1 joule is the amount of energy required to do 0.74 foot-pounds of work. And what that really means for you in terms of electric fencing is that the joule released by an energizer during each pulse determines how effective the power is coming out of that box, how much wire can be charged by it. Watts are units of rate for electricity. So the joule is the energy used to produce 1 watt in a second. Amps are the unit of flow. So an amp would be how quickly something is moving across the wire. And coulombs are electrical charge quantities. So, let me see if I can get to another one. Volts would be the pressure. So a lot of times people will talk about electric fencing and they'll talk about voltage. I like a water analogy. I think Jeremy likes the horsepower analogy. You'll hear both of them here today. But I think of voltage as a pressure term. So for me, this makes a lot of sense. The resistor is any component in the electric fencing system that because of the materials, what it's made of, the shape of something, it offers a restriction to the flow of electricity. So where we talked about metal being really good at moving electrons, but that one wire is much bigger than the other wires, those small wires in the poly would have more resistance to the flow of those electrons than, say, a high tensile wire. And we measure that resistance in ohms. An insulator is a substance that will not allow any electron flow and is used to stop electricity from leaking. That's why we call them insulators when we put them onto our fence. They are essentially designed to stop any electricity that's moving along the wire from moving into our posts. And conductors are substances that allow electrons to move smoothly. This would be, typically our wires are very good at this. A lot of our steels are good. There's a reason we use copper in our houses. It's because it's a very good conductor. The unit of conductance is called a mho. I just think that's a really fun fact there for anyone in the room. It's just the reverse of a ohm. I don't know who had that sort of humor, but it works for me. I don't know. A leak is a low conductance, high resistance pathway from the fence back to the earth return. This is sort of a fun one. A lot of times people will say, oh, my fence is shorted, but they still have charge on their fence. And it's still working to some extent, but it's not working perfectly. Most likely what they have is not actually a complete failure of the fence. They have leaks on their system, places where energy is trickling off of that fence and working its way back to the ground slowly. They can be caused by cracked insulators, grass. It could even be a length of the wire in contact with the ground, but not in the ground itself, where it's just sort of shorting against the ground with a little bit of grass sitting between them. And animals, in most cases, when they touch it, are a leak. Very rarely do they drain a fence completely when they touch it. I guess if you had enough animals at one time, they could be a leak. But in most cases, animals don't, if we've built our fence correctly, they don't actually kill the fence, they just leak a lot of power. Shorts, on the other hand, do have a high conductance, low resistance pathway. That's where the live wire touches a neutral wire or a ground wire, or literally we stick our live wire right into the ground itself or into our grounding system. Often on a hot ground fence, these are known as wire-to-wire shorts. And when this happens, you won't find any voltage on your fence at all. There are two styles of energizers out there on the market, and one that you really see being sold today, and that's a low impedance energizer or charger. They use really high voltage at really short bursts. They come through 330 pulses per second. And one of the benefits of this low impedance design is that it doesn't have the fire risk that previous older electric fences had. The high impedance chargers actually put 2 pulses per second, so they are much longer pulses of power going out. And that's something we would not necessarily want to use, especially with polywire or where there's a lot of foliage or vegetation, because those long pulses can put enough energy out that we can create that fire risk that we used to hear about in like the 80s, for those of us that remember the 80s, and even into the 90s, especially in some of the western states. And I promised you a water analogy here, but this is how I visualize electricity working. If our fencing system was a water system instead of a fencing system, the height of the water tower is the joules that we're getting out of our charger. So however tall that tower is, however high up in the air that is, that's going to give us the amount of capacity for our system to push water out, in the same way that the joules on that charger are going to tell us how much energy we can push out on our fence. Any water flow through our lines, our pipes, would be considered the same as our amperage on our system. So anytime water is flowing, it would be analogous to those electrons flowing along the fence. And the pressure that we receive in the shower would be our voltage. That's how we receive or feel the reaction of the system. So we don't necessarily say how much water is coming out in gallons when we take a shower. We say, do I have enough water pressure to get the soap out of my hair, right? And that's how the animal's going to receive or feel the fence charge. A running toilet in that house would be analogous to a leak. There's going to be some water running continuously through that system. We're going to keep using water from that tower, but we're never going to have so much water running out on the back end that we can't take a shower. It's probably going to make a minimal difference in what we're going to experience if we have a small leak like that. But when I break that water line driving fence posts, it happens often, that's a break in the system, right? That's a break in the water system, and all of a sudden I don't have any water pressure in my house at all. And that's a short. That's a short on an electric fencing system. And that is how I think of electric fencing in terms of water. Are there any questions?
Every time I put an insulator on a wooden post, I think, why am I doing this? Because posts are not, wood is not conductive. Why do I need an insulator on a wood post?
Wood is not necessarily the most conductive, but it is not an insulator. There is actually a fairly good amount of moisture in wood, and the wood post will be a leak, for sure. Also, typically what we have, it depends on how we have our fence set up, but also we often have multiple wires on that, where some wires are hot and other wires are either neutral or grounded. And certainly if we have those wires in the system, then we're not even talking about moving that electricity very far between wires. So even if we don't even have to get it from the top wire to the ground, we only have to get it to go about 4 or 5 inches across a piece of wood, and it's slower moving there, but it is not going to stop it by any stretch.
Is there any other questions?
I was hoping you could talk a little bit more about grounding in like a large stretch of fence. Excuse me. Grounding in regards to a large stretch of fence, like a full perimeter, as an example.
So generally around here, our recommendation for grounding is 3 ground rods, 6 feet in the ground, 10 feet apart. That's for larger perimeter systems. That's what we want in terms of a surface area. And the reason we want those 3 in different spots is so that they have contact with soil for the ion exchanges, and they have enough surface area to do that. If we went to like a huge farm, you know, hundreds of acres, and we've got, let's say, a mile of fence or more, we would have to potentially add more ground rods into the system to be able to absorb all the energy that's out on that huge fence. We're gonna touch on the grounding system outside as well. Yeah, we'll show you how to do some testing on it then outside.
Okay. Well, the reason, I guess it's not as big of an issue. I come from a drier state where grounding is a very serious issue, and we almost have to have it go completely around the fence along with it. Is that something that is an issue here? Okay, fantastic. That's great news. Thank you.
Yeah, no, because we have 2 things here. We have clay soils, which are pretty good. They're not high mineral soils like you'd have out west, and we have a lot more moisture here. We have a lot of spots where people get away cheating the system and not putting all 3 in, and they still work. But around here, that is not, the recommendation is the 3, because when we have droughts like we did last summer, we need that surface area for that contact. I would say most people get away with less ground rods than they should have, but we'll talk about what you should do to check to make sure you have enough ground rods when we're outside, when we look at that grounding system. Yeah.
Can you, when you talk about woven fencing or fencing high tension, would Red Barn be considered a high tension?
Most of the red wire, I think all of that is still standard woven, not fixed knot high tensile. Yeah, the fixed knot high tensile, there's a number of companies that produce it. Around here, the ones I see most often at farm store are what? Gaucho, Bakert, however you say that. And Stay Tough, yeah.
So we'll have, in April, a whole day workshop on putting up fixed knot high tensile fence and smooth electrified high tensile fence.
For permanent systems.
For permanent fencing. So if you're interested in that, you need to come to one of those workshops. They're really a good hands-on workshop also.
Yeah.
We also have more in-depth electric fencing workshops too.
Yeah.
Good, there was a question here.
What is your thoughts on stray voltage? How does this fit into this? I hear some people say it's real, some people say it's not. I would like to hear your thoughts.
Stray voltage is real. Stray voltage is real. Fences don't typically give us a lot of stray voltage. Interestingly, we have a lot of voltage in the system, but we don't have a lot of power in this system compared to other things. Where we tend to see more stray voltage, and the reason we see it on dairies is because they have a lot of power demand. We tend to see it sometimes with tank heaters. We tend to see it with improper grounding in a barn. If you're seeing it, and electric fencing is one of the primary things that you're doing with electricity on the farm, my guess it has to do with the grounding system on a 120, 240 plug-in. Like it's probably in your base electrical system on the farm itself. And stray voltage occurs because of noise essentially in the system. It's because our I don't want to go into this too much. It's because our power isn't lined up the way it needs to with each other. Like all of our things aren't pulling power at the same point in the cycle the way they should.
Yeah, I have farmers that ask me about stray. I work for organic valley. They ask me about stray voltage all the time, and I just don't know enough about it. And it's like enough to make it worse. And so, like, anything you can talk about is anything.
So the things I would say is if you have stray voltage, you want to check your grounding systems. You don't want too many grounding systems. A lot of independent grounding systems on a farm that are separate from each other makes confusion in the soil. Like it doesn't ground well because they're each running on an independent ground, but the energy's interlocking between the systems. So that is one thing to keep in mind, that you really don't want a lot of different grounding systems close together. Oh, I got another one now. I think the recommendation, at least for the ground system, is what? 33 feet? And I think if the soils aren't as good, it's 50 feet in other parts of the country. Around here, though, 33 feet is enough space that they're independent from each other. So, like, if I'm putting my ground system for my electric fence here, I don't want to start it here, and then my one for my ground rod from my electrical on my house is right here. I do want space between those systems. And if I want to put in something for, say, lightning arresting, I don't want that on top of both of these either. I want each of them to have a different amount of soil associated with them to take in the power that they're supposed to absorb.
I know this would vary tremendously based on the length of fence, but what is an example of an electric bill that you would see?
Oh, so we've done a bunch of work on this, and we're talking about probably cents, maybe $1 or $2 a month. It's very minimal. It's minimal power. Yeah. I think we've seen, like, even the big ones would be like $5 or something a month. It would be. Yeah. Yeah, it's one of the tricks is that figuring out, if you don't have other electric demands on there, it's hard to put in a plug-in system, but also they're so much cheaper to have the plug-in energizers that a lot of people still, if they have electric there, they're going to use it.
Are we ready? I didn't know whether or not a part of the presentation covered fencing responsibility. We happen to be on a farm that has cow operations on every side. And I think someone said, you know, we're kind of new to farming, but that if you stand in the middle of the fence, then your responsibility is to the left and your other farmer's responsibility is to the right, or vice versa. But as far as the legality of that, of course, we all want to be friendly farmers and get along.
Yeah, with the fencing school, we have a person who specifically speaks about fencing law, but here in Kentucky, we are responsible for our own animals. We are liable for our own animals, but we and our neighbors have an agreement that if one of us has animals, we both are responsible for having a fence. But when they get in the road and someone hits one, it's my fault because it's my animal, if that makes sense. So yes, we want to be respectful of other people, but yes, our neighbors, even if they don't have animals, if they are a farm adjacent to a farm that has livestock, they also are responsible for having a fence on that perimeter, and they're responsible for half of it.
All right, so we'll move on, and that's a great question about fence law. We actually have a very good speaker on fence law at our fencing schools that we're going to be having in April in Richmond and Scottsville, Kentucky. So it's a whole hour presentation on fence law. It sounds boring, but it's probably one of the most interesting presentations in the fencing school. So now we're going to move on to our second speaker, and we're fortunate to have Jeremy stationed right here in Kentucky in Muhlenberg County. And Jeremy works for Gallagher Fencing. And how long have you been in the fencing business, Jeremy?
17 with Gallagher and 19 in the
19 years in the fencing industry. So he's got a tremendous amount of knowledge. And I would encourage you to ask questions today, and he'll be around after we finish up for a little bit. So if you have some very particular questions, he can help you out with those too. So with that, I'm going to turn it over to Jeremy.
Thank you. And I used to be able to make most of this up until we started bringing the engineer in with us. So she keeps me honest. April 11 and 13. Those are the dates for the two UK Kentucky fence schools. So keep an eye out for that, and we get really, really deep into the topics, especially on the fence law part and the permanent construction part. So what we're going to focus on for this presentation is just some basic concepts and troubleshooting, and also some common misconceptions possibly with electric fence, and maybe why it doesn't work all the time. And you have okay. And as a cattle producer, my wife and kids and I run a small grazing-based operation in Muhlenberg County. And as a producer, if there has been a shortcut that can be taken, then we've taken it. And if there's been a problem that can be had, then we've had it. And so we've learned a lot from our mistakes over the years, and we know what shortcuts we can take, but we also know the ones to avoid. And hopefully by the end of this, you all will have a little better understanding, and we'll have some time outside in the field to get hands-on, and also to answer any questions that we didn't get beforehand. Are both of these mics on? Okay, good. So with that being said, how many of you all have used some type of electric fence in the past, some type of power fencing to control animals? Okay, great. And one thing to keep in mind is these same concepts that we're going to talk about, they can also be used for exclusion, which is also a huge part of what we deal with in the industry, is not just keeping animals in, but keeping animals out, keeping predators out of our small ruminants and cattle, and also keeping nuisance animals out of our vegetable and fruit production. So these same concepts will work both types of fence, exclusion and inclusion, with a little bit of a tweak on design. And we can talk about that later at the end if you have questions about exclusion with electric fence. So of all of you all that raised your hand that you have used some type of electric fence in the past, and I'm sure all of you have always had 100% good luck results out of it all the time, right? And there's usually one or two people that will admit, yes, I've had pretty good luck out of it. So one thing that we have to keep in mind immediately when talking about power fencing is that it is a psychological barrier. Now, there's a big difference between a psychological barrier and a physical barrier. Some of the designs that were shown on the price comparisons earlier were physical barriers. Woven wire, barbed wire, plank fence, those are all designed to physically keep animals from pressuring the fence. What we learned in the 70s and 80s is that we could take a physical barrier, which wasn't very effective, which was the multi-strand high tensile wire with no electricity. It's not very effective when it gets slack, but we could take that and apply safe, effective electricity to it in a pulsing manner, and have a very effective psychological barrier. As a matter of fact, it's so effective that we can use those same concepts and products and materials and designs to control all of these animals. So all these animals in about every zoo in the U.S. and several around the world and all the major theme parks, we're using the same concepts to control these critters as what you would use on your operation to control cattle, sheep, goats, horses, or even to keep deer out of vegetable production. However, one thing to keep in mind is that the giraffe exhibit down at the Nashville Zoo or the gorilla exhibit up the road at the Louisville Zoo, they're probably not going to take the same shortcuts that us in this room would as livestock producers. They're probably not going to try to get away with some of the little silly things we do, like using water hose for insulators. I know nobody here would use a water hose for an insulator, but you've probably seen your neighbors do that. So, you're not going to find a water hose as an insulator at the Cincinnati Zoo. You're not going to find the Louisville Zoo or the Knoxville Zoo using something that is clearly designed for house wiring, like this Romex cable that is clearly stamped 660 volts. You're not going to see that zoo use this as a lead-out wire for their electric fence. And also it's copper. And we never want to mix metals, and we'll talk about that in a minute. So the point that I'm trying to get across is if we can control all of these animals effectively with power fence, and at the zoos and these major theme park exhibits, a lot of the times you will not see the power fence because it's designed as weeds and grass and vines, but it is the primary barrier to keep these animals off of that physical barrier that you're actually looking at between you and the exhibit, which could be a moat or a high fence. But that psychological barrier exists, and it is the primary barrier to keep these animals back. So if we can do this with these animals, which are obviously some are wild and dangerous and very large and can get grumpy in captivity, then why in the world can we not do that with these animals? In this case, with a single strand of temporary fencing to not only control where these animals are, but also to control our forage supply and our forage allocation to these animals. We can do that with a single strand of temporary fence interior if the system is designed properly and we don't take too many shortcuts. And I'm sure you've heard this several times in the last day and a half, and you'll hear it more tomorrow in little bits and pieces of presentation. But rotational grazing, managed grazing, intensive grazing, any type of managed grazing is one of the most easy and simple and effective practices that we can do when trying to reach a goal of sustainable agriculture with animals. And with electric fencing, which is highly portable, then we get to make the decisions. Those animals don't get to decide where they're going to graze at and how long they're going to graze there, but with that simple single strand of some type of poly product with a few thousand volts on it, we get to make the decisions. It changes the whole dynamics of the operation. And in this case, these animals are in late December and they're grazing stockpile fescue, which has completely alleviated the need for stored hay for most of the dormant season. And to get a little more bite of this, then I'll put a plug in for Kentucky Grazing School, which Dr. Teutsch will probably mention later, and that's coming up in April in Princeton. And so it barely touches the surface on the fencing part, but definitely gets deep into the weeds, no pun intended, on the grazing part. So, fact is, we can control these animals if they're trained to it and if the system is built properly. So, when building a system and designing a system, then planning is important. We'll talk a little more about planning here in a few minutes, but a few questions that you need to determine and answer ahead of time is how big of an area are you fencing? Is it going to be temporary or portable or a combination of the both? Is it for exclusion of predators, or is it strictly for keeping animals in? And that's the keeping animals out part. For you all that are involved in small ruminant production, that's just as important as keeping those sheep and goats in. And there's some design considerations once we venture into the small ruminant category as well. And so as a side note for voltage, Dr. Hayes touched on voltage a little bit. The recommendation that we see from most universities and animal physiologists would be about 3,000 volts for cattle, 3,000 to 4,000 minimum, absolute minimum, that the cow must feel, so effective voltage. Horses are about the same. Sheep and goats, you need to hit that 5,000 to 6,000 effective volt mark. And it's not that hard to do, but sheep and goats are definitely a little more of a challenge because they're walking around on little bitty ground rods, because they're walking on ground rods. Small surface area on their hooves means it takes a little more power to get that complete circuit that we saw earlier. So figure out these questions first before you start to design a system. Temporary fencing is a great way to find out the flexibility that you will need on your operation before you start adding permanent fencing or permanent cross fencing. Regardless, to hit on the same subject again and again and again, power fencing is a system, and we have to think of it as a system. And if one part of that system fails, then the whole system can fail. Coincidentally, we see most failures occur with the ground system. And these are the three components you saw about 10 minutes ago. There's one component that we often forget about, and that is the lead out. So that could simply be the cable, the piece of wire that goes from the energizer to the fence itself. Now, we can have a perfect ground system. We can have the largest energizer in the world. We can have a brand new insulated electric fence system, and then use an old rusty piece of wire to go from the energizer to that brand new system, and all the voltage gets choked down that piece of rusty wire because rust does not conduct electricity. Remember that because it'll be important in a minute. Rust does not conduct electricity. So all three of those have to work together. The system fails. Low impedance energizers are pretty much the standard now. There's not many manufacturers that even offer an alternative to it. But low impedance technology is very easy to find. The million-dollar question is, what size and how do I compare energizers? Because you see all of these different ratings on the box, on the retail packaging, and those ratings are put there by marketing departments of companies that want to sell you things. And sometimes the marketing departments may not stretch the truth. They may just nudge it a little bit when it comes to ratings and some fancy call words. So you see all these different figures. You'll see mileage and joules and stored joules and multi-wire, or maybe it just says X number of miles and doesn't say if it's 1 strand or 15 strands. Some will just say super shock 'em hot. So what in the world do we use to compare energizers, to compare fence boxes between brands or within a brand for that matter? So one thing that's fairly common that we see estimations for mileage. Now keep in mind there is no industry standard across the world on mileage of electric fences when it relates to ratings on the box. But if I want to take it for exact wording and I put it in perspective of how many miles are around certain given sections of land or given areas of land, that I can get a little better feel for it. So if an energizer, so first let's think about what goes on across the Mississippi River and a lot of the ground in the Midwest and the West. So somebody here said they were from an area that was a little bit dry earlier. Who was that? And what state was that? California. You see a lot of farms and ranches are laid off in big squares, perfect square perimeters. You see a lot of that in the Midwest, and those are sections of land, and a section of land is a 1 mile square. So that means on a square section out of Missouri or Kansas that I can start at the beginning of that 640-acre square, and when I come back to the end at the beginning point, it's 4 miles. A section of ground, 640 acres, is 4 miles of perimeter. So if that's the case, if I see an energizer that's listed for 4 miles, then I should be able to take that energizer out to Oklahoma and put it on 640 square acres, and it should electrify it properly. Right? That's what the box says. Nevertheless, a lot of the 4 mile energizers will cost somewhere between $50 and $75. So you think, well, that may not exactly be realistic. So let's take it one step further. So let's go out to New Mexico, where there are hundreds and thousands of acres of square ranches, because a square is going to be the most suitable perimeter for distance estimation. So let's take a 400,000 acre square ranch in New Mexico or Nevada and start at the beginning and drive all the way around it. And when you get back to the beginning, your odometer says 100 miles. So theoretically, I should be able to take that $300 Energizer that says 100 miles. Boy, that's a hot one. I should be able to take it out to Nevada and put it on a 400,000 acre ranch and expect it to be effective. Right? You're not too convinced. So keep in mind, these are estimates. There is no magic formula. These mileage ratings are best used within brands. If you take brand A and they've got a 100-mile fencer and a 25-mile fencer, you can say, okay, the 25-mile fencer is probably about a fourth of the power as the 100-mile, and vice versa. But don't compare across brands, because each marketing department has their own creative designer that get more creative than the others. So let's just go ahead and mark mileage off the list of accuracy. And let's look at something else. Joules. Dr. Hayes mentioned joules. This is like horsepower, or this is the ability or the capacity to do work. So joules is pretty much an industry standard for rating electric energizers or electric fence boxes. Joules are not something that can be really exaggerated because they are measurable. No company is going to try to fool somebody on the joule rating. So now that we have a horsepower rating or a joule rating, then maybe we can say, okay, somebody has got to come up with an equation, surely, on how many joules per mile. How about that? Sounds simple, right? So let's forget about what the companies say, because the companies just want to sell us things, and they may inflate it. So most companies are going to be around maybe 0.2 joules per mile, or some will even go half of that and say 0.1 joules per mile, which is significantly different. And then the same companies that have operations in New Zealand, where we invented electric fence, versus in the U.S. The New Zealand ratings will be vastly different than the U.S. ratings for some reason only that marketing departments know of the exact same energizers. So let's forget about what the companies say, and let's look at maybe Extension or NRCS that has a research arm to their work that's going to be hopefully more credible. So if we look at NRCS in Tennessee, which has done quite a bit of work, a lot of cost share on electric fencing. NRCS in Tennessee says, okay, well, the companies say 0.1, 0.2 joule per mile. We're going to say it's more like 1 joule per mile. So it's going to take more power to get the job done. But then we look at Missouri Extension, and they agree with Tennessee NRCS. Missouri Extension has produced several publications on power fencing, and they say, yes, 1 joule per mile is very realistic, we think. But then let's look at maybe California Extension and Minnesota Extension, which have both done as well a lot of work with electric fence, and they're back down to that 0.2 joule per mile range. It's so confusing, right? Because nobody can agree on how many joules will do X number of miles of fence. Well, the answer is, and this is a very honest answer, it depends. It depends. How many joules per mile depends on the type of fence, the type of conductors that the fence is made of, how many weeds and grass, how much weed and grass load there is on the fence, how many poor, pitiful connections there are between gateways or going across water gaps. It depends. So there is no magic formula, but what we do know is that what you're paying for is the horsepower. Just like when you go buy a tractor, you're paying for the horsepower. Now you can pay for extra features like cab or air conditioning or extra hydraulic remotes, and those things add up. But initially you're paying for the horsepower. The more horsepower you want, the more you're going to pay. With electric fencing and the energizers, the more joules you buy, the more the energizer is going to cost. We're paying for joules. Not to be confused with voltage. Voltage would be very similar to not only the pressure that Dr. Hayes talked about, because if there is no pressure, the water does not move down the water pipe. It just sits there static. But voltage can also be compared to the RPMs on a piece of machinery. If you have no RPMs, the engine's not turning, or if you have low RPMs, the engine's not turning fast enough, and when you put the load behind the tractor dies. Low horsepower tractors cannot pull very big loads. Low joule energizers cannot pull very big loads either. And loads are adding fence, adding grass and weeds. Animals can be loads for short periods of time. So the more joules you have, the more power you have, the more potential to do work that you have. So power supply options, the main thing to remember here, and there were a lot of questions earlier about the 110 volt plug in the wall energizers. These are going to be the most efficient energy wise. They're definitely going to be the cheapest cost per joule, because joules is what we're paying for, but plug-in energizers are going to be the cheapest cost per joules as compared to a battery only or a solar, which is essentially a battery energizer with a solar panel backup. From an environmental standpoint, we feel that probably the least impact is going to be with the plug-in-the-wall energizer with today's energy-efficient versions, because you don't have to worry about dealing with disposal of gel cell batteries. Typical gel cell batteries in these solar energizers, you will get between 2 and 4 years out of, and then you have to go buy another battery, then dispose of the one you have. Plus, there's more material in the solar. However, there are some cases where 110 volt mains power is not available, so that's why you see so many solar options available. Just keep in mind that for solar options on power fencing, you're going to pay somewhere between 3 and 5 times the amount of money for the same horsepower if you go with solar. Everybody understand that? You're going to pay 3 to 5 times more per joule with the solar option. So keep that in mind. Don't think that if you have $200 to spend that you're going to get the same power for a $200 solar as you would have a $200 plug-in. So be prepared to spend maybe the $400 to $600 range to get the same power out of a solar. And we do understand there's instances where you do not have access to 110 volt power. So another illustration on how the fencing works, and this is why the ground system is so important, because if you think about it, when that animal walks up to the fence, and this is an example of a 3-strand all-hot fence, when that animal walks up to the fence and touches it, the electrons flow back through the soil to this ground system here, and for a brief instant, these ground rods do get hot. They have electricity flowing through them because that's how the circuit gets completed. So the ground rods will get hot for a brief second when the animal touches the fence. This is like an antenna. These are conductors. Now, some people are tempted to use a rusty piece of rebar as a ground rod. Some of you may have neighbors that use T-posts for ground rods. T-posts are not a good conductor because they rust under the soil, and paint and everything else is not a good conductor. So that's why we recommend 3 galvanized ground rods, 6 foot deep, 10 foot apart, because that rusty piece of rebar does not conduct. Somebody's laughing. Does your neighbor use a rusty piece of rebar or something? I've seen some smiles around. So Don't make fun of your neighbor if they're using a rusty piece of rebar for a ground rod and their animals keep getting out of the fence. This is a good opportunity to go home and explain to your neighbor, because you want to have good neighbors across the fence. Explain to them that maybe the recommendation for 3 galvanized ground rods, 6 foot deep, 10 foot apart, is probably a little better alternative. And to back up one slide, the alternative that we have to use in the desert west or in drier climates or in high mineral climates would be an earth return system. And in this case, we actually have alternating wires in the fence that are grounded. Now, we're not talking about a neutral wire that just is there without any type of connection back to the ground rods, but a true hot ground system is pretty in-depth from a design standpoint, because every time that you go under a gateway, you're going to have to go hot wire, obviously, and ground wire. Because a true hot ground system, this ground wire, that middle one there that's blue in this case, would have to be connected all the way back to the original ground system of the Energizer. Now, you can randomly put some ground rods around that system off of that earth return, but at the end of the system, it has to be connected to the same ground system that is then connected to the ground of the Energizer to make a complete loop. Otherwise, it's not a true hot ground system. So there's a lot more design consideration. I've seen very, very few of these in Kentucky and Tennessee in the last 17 years or so that were actually built properly. But if you do have a system like this, an animal walks up and touches both of those wires at the same time, it is an instant shock. It's no different than the animal walking up to the Energizer and sticking its tongue on the ground and its nose on the hot, and there being that much resistance between the two, and it's an instant shock. However, if you're fencing through a wooded area or an area that has trees over it, and a tree limb falls and mashes wires 1 and 2 together, what do you think just happened there? Short. A dead short, just like taking a screwdriver to the Energizer and shorting out the hot and ground terminal. Because the system's designed properly, it shorts out. Now, we don't want it to do that, but that's what happens when you get those 2 wires together. Now, in the system that I prefer, in this case where all 3 of those strands are hot, if a tree limb falls and mashes strands 1, 2, and 3 together overnight, it's not a big ordeal. The tree limb is fairly low resistance. If the system is built properly, we can mash all 3 of those hot strands to the ground, and that 2-foot section that log is laying on the fence contacting the ground will not be enough to completely kill the fence. Even though the high tensile wire may be laying on the ground, embedded into the soil an inch or so, it should not be enough to kill the fence dead on a properly grounded system, because we do have some resistance that builds up in the soil to get back to the ground rods. So, yes? It just shorts the box out, so that it shouldn't trip any breakers. It shouldn't affect your mains power supply, but it will stop the box from the electrical output. Yes, but that fuse is for the mains power side for surges, not for shorts on the fence. So it's a separation of the 2 systems. And you had pull those wires apart, it would be hot again, you wouldn't have to go back. Correct. Yeah. You had a question? Yes? So the question was, if you have your underground cable in a protective pipe, if the pipe gets crushed, can that affect the fence? No, it does not affect your charger, no. Yeah, right. It stops the pulse. When you remove the short from the fence, then the Energizer will ramp back up in most cases. It would take a long time of shorting to damage modern components. Now, 20 years ago, it may have been a little different story, but every manufacturer now, with low impedance, it's not going to be a huge issue if the fence stays shorted out for a long period of time. Hopefully it does not, stay shorted out for a long period of time. But if it was on an area that had no livestock and you just kind of let it go and left a fence on, then it would take months to damage the components internally. So those are the two types of systems. Again, in this region of the U.S., I prefer the all-hot system because it's easier to design. I don't have to worry about tracing my ground wire every time I go under a gateway. And most of all, I can use this in wooded areas and not have to worry about getting two wires contacted together and shorting the fence out. So the recommendation, and this is not just me or the company I work for, this is agreed upon by most every extension service in the U.S. and NRCS national standards. The recommendation is 3 ground rods, 6 foot deep, 10 foot apart. That's the minimum. It is recommended to use galvanized ground rods and galvanized wire to join those rods with. Copper is a great conductor, but copper absolutely despises other metals. It's such a good conductor. And if you join copper with galvanized, then electrolysis will occur because it's 2 different types of metal. Electrolysis will occur and you will destroy the other metal. The copper will literally cannibalize the galvanized or eat the galvanization off the wire, and then the wire turns black and falls apart. So don't mix copper and galvanized. If you're using a copper ground rod and you join a copper wire, like in this Romex, if I join this copper wire to a copper ground rod, no big deal. I have copper joined to copper. However, when I join that copper ground rod, that copper ground wire, then to the galvanized terminal on my energizer, electrolysis starts, and I will eventually burn right through the galvanized terminal on my energizer because I'm using a copper wire. Do not use copper in your electric fence systems unless everything is copper, and that's not likely to happen. Yes?
I got a question about that specifically because I use turbo wire with the three copper and 6 galvanized, I believe.
Yes.
So if I'm making a connection because I'm crossing a paddock and I'm doing polyline to polyline, and I think Gallagher sells some, but I make them. If I make like a little wiggle out of a piece of not a scrap piece of high tensile fence to kind of get those together, am I risking corrosion?
You're not
Because of the copper lines and the turbo wire?
with that specific product you're talking about. There's a tin coating, a TIN, the element tin. There's a tin coating on that copper. A couple other brands that make a high conductive, they will also coat it with tin or another metal. The copper adds the conductivity, but that tin coating keeps it from burning other metals into. So, but joining poly wires is definitely a concern. It needs to be joined the proper way and also jumped a proper way. So jumping it like you're doing between 2 fences, you want to have a good tight connection. So whether you're using an alligator clamp or a hard connection with a gate handle, then you want to make sure that those wires are making good contact. And that's something we can talk about more in the field as well. I think we have an example possibly of a piece of spliced poly wire. How are we doing on time, Dr. Teutsch?
We've got about 15 minutes until break.
Okay. So the main takeaway point here, do not use copper ground rods or wire unless you're in Tennessee. And Tennessee Extension has a 1974 fencing manual that still says to use copper wire on a galvanized ground rod. Don't ask me why. Is anybody from Tennessee Extension here? Okay. I haven't found the answer yet, and we've done numerous schools in Tennessee, and all the extension folks just kind of shake their heads. So unless you're in Tennessee, don't join copper with other metals. But once you cross the border, then mysteriously copper has different properties there. So that's like your antenna. Very easily compared to dish network or rabbit ears. I see some blank stares. Rabbit ears would be like using a piece of rusty rebar. In the 80s and late 70s when I was growing up, we didn't have this thing called dish network, and you had these little wires on top of your TV, and sometimes you could put aluminum foil on those little wires and maybe pick up the Bowling Green station a little better on some days if the wind was blowing right. Rabbit ears were pretty crude. A copper or a rusty piece of rebar is like rabbit ears. I'm not going to reach out very far to pick up that signal. 3 ground rods, 6 foot deep, 10 foot apart would be more like Dish Network or some of the new modern technologies. I can reach way out to pick out the signal. And I want to reach way across the farm and pick up the signal of the cow, the sheep, the goat, the neighbor's dog that's trying to get my sheep. I want to be able to pick that signal up and effectively shock that animal. Resistance, this is more of a good point for a permanent system. Multiple wires conduct much better than single wire. So the more wire we have on a proper built system, the more conductive the fence is, the less resistance. Those wires have to be combined in parallel. So on a 3-strand fence, I would want those 3 strands. They would have to be jumped at least at one end to make the other ones hot. But on a 3-strand fence, I want to jump those wires up and down, 1, 2, 3, at one end. And then the next time I terminate that fence at a brace assembly or a gateway, I want to jump those wires again, 1, 2, 3. Or if it's 5, jump them all 5 together. I want them connected in parallel. So they shouldn't just be connected at one side and just run out there dead to the insulator. They need to be jumped up and down every termination point. When I do that, that becomes a parallel connection, which then decreases my resistance. And it's a very simple fact of electrical theory that my resistance, my ohms, decreases every time that I add another strand of that 56 ohms per mile high tensile resistor. This is something that we get into a little deeper at the fencing schools. So protecting your investment, if you're in a lightning prone area, then your ground system is a very, very easy and cheap. We all like something cheap as livestock producers. A ground system is the cheapest way to improve your fence system. The better the ground system you have, the more lightning protection you have. Now you can add surge protectors on your mains, on your plug-in, to protect those surges coming out of the outlets that your Energizer is plugged into. You can also add external lightning protectors to your fence. Some can be adjustable where you can adjust the gap between ground and hot to try to divert that lightning into the ground. And the easiest way is to add more ground rods. Now in extremely lightning prone areas, there's a very simple design. It takes a little bit more area of what could be considered wasted ground, but in a lightning prone area, you can drive your ground rods in a circular pattern, so it could take a 20 or 30 foot diameter circle, but you drive your ground rods in that circular pattern with a common rod in the center, all those rods connected together, and then to the common rod, and then to the Energizer. And the theory is that lightning does not like to travel in circles. So hopefully it dissipates before it completes that circle and goes to the Energizer. But that's in extreme cases, and you're going to sacrifice a 30-foot diameter circle somewhere that you're probably not going to want livestock in unless you completely bury your system. So layout and design considerations, the easiest thing you can do is to get a piece of graph paper and a pencil and draw this stuff out before you start building permanent fencing. And if we're just talking about temporary fencing, before you get out and start stringing out poly wire on a reel and putting step-in post in, then there's several tools that you can use that are internet-based to see just how far it may be across this field or that field, or would it be best to cut this pasture up this way or to cut it at a diagonal or cut it this way. You can do that using something as simple as Google Maps. You can also get a printed off version of your aerial photographs from the Farm Service Agency and use the scale. One thing that I like to use is the Kentucky Commonwealth map. And it's kentuckygeonet.kentucky.gov, or you can go to Google and type in Commonwealth map. And this is every county in Kentucky. There are multiple years of aerial photographs. Probably the biggest benefit that I have got out of this, and a lot of other producers have got out of the Commonwealth map system, is that there are aerial photographs going back to at least 2003. So if you have taken over a farm or bought a farm or rented a farm, and there are maybe some mirror fountain water scattered around it, or there's some frost-free water hydrants, And you know there's got to be water lines going to them, but you don't know where those water lines are, and it's not real fun just to go driving posts in the ground to try to find those water lines. Then what you can do in a lot of cases is if those water lines were put in the last 20 years or so, you can go to the Kentucky Commonwealth map and look through those multiple years of aerial photographs and probably see a trench that's within 2 years old when those photographs were taken. So that's a great tool for that. And also I can go through here and I can trace out area. So I can figure out area, how many acres are going to be in these division paddocks, and I can also easily figure out length to figure out how much polywire I may need. So anyway, good free tool to use that the state of Kentucky updates regularly. So some take-home points. Use larger wire when possible on your permanent fencing. 12.5 gauge high tensile is kind of the gold standard of a baseline. The 17 gauge and the little 14 gauge wire. Not a very good conductor because there's not much surface area around the outside compared to the 12.5 gauge. Don't overlook your lead out wire, and we'll talk about a few examples here in the next 10 minutes or so before we break. Don't mix metals. Do not mix copper and galvanized. And then also planning out your design beforehand. It is a system. Power fencing is a system. Now we could just cobble together some old rusty wire and some insulators and some T-post and call that electric fencing. But for a power fencing scenario, we think of it as a system. All the components of the system have to work together, and we cannot take shortcuts and expect an effective system. So modern technology the low impedance energizers that Dr. Hayes talked about, they can effectively shock through weeds and grass compared to the old technology of the 70s, but we cannot perform miracles. It will take some type of control, whether it's mechanical or simply adjusting your design where certain classes of animals will graze under that fence line. And animals can be trained to graze under a fence line, especially if we're talking about a single strand polywire fence that may be at 32 inches or so high. So if this was on the ground, then we're looking at about right there for a wire height. Animals will graze under that fence. Otherwise, on a multi-strand fence, if we're down to that 12 or 18 inch range, then mechanical control will be required. Also, just some common sense on different types of insulators. We want insulators that will remain in place, use some type of a locking device, whether it's a pin lock or a W-style claw. We don't recommend these little 5-cent doodads that you have to drive a staple over. If you drive the staple in too tight, you compromise the plastic. If the staple's not driven in tight enough, then the thing slides out of the way and it's not doing a good job of insulating if it's not there. Also, these wraparound tube insulators. You've probably seen some of these before. These used to be the cheapest option. They're no longer the cheapest option, but these are not recommended because you can get hairline cracks, and then once those hairline cracks occur, you start getting leaks. One leak is not a big deal. If you have 300 of these on a farm and they all leak a little bit, that's a big deal, and they're impossible to track down with a fault finder. Also, I think in 2018 or so, NRCS in Kentucky, as well as some other states, they took these wraparound tube insulators out of the specs that they would cost share for because it does not meet the minimum lifespan of a fence when you're using government cost share dollars. So these do not meet the lifespan because they inevitably wind up looking like this, which is a cracked piece of plastic that no longer insulates. So stay away from those shortcuts. Don't use gate handles like in this picture. Don't use gate handles on a semi-permanent or permanent fence to conduct your electricity going across a gateway. On polywire, it's perfectly fine. We can use gate handles to conduct. If it's a permanent fence, we never want to use gate handles to jump that power across because we can get resistance built up in the hook and the loop part of the system. We want to go under the gateway with a buried underground cable, a double insulated cable designed for electric fence. And then also using the right tools. You can see at the top of this picture, somebody has very cleverly engineered an antifreeze jug and use that to hold their temporary wire. And that's probably the last time they'll ever use that, because when they try to unroll it again, they're going to have a big mess that'll go to the scrap pile. So there are reels that can be used to store your temporary fence wire. Those of you all that go outside with us after a while will get a chance to use some different types of reel. Bracing, we go to the depths of the earth to describe bracing and how to build it and build effective bracing in the Kentucky fence schools that are going to be in April this coming year. And there's just a lot going on in this picture we don't even have time to discuss, but you've got rusty wire and broken insulators and all kinds of things. And these are the things to look for if you're renting a farm, or if you've purchased a farm that has fence on it to begin with. And look for some of these places where you've got corrosion occurring, where maybe you've got some arcing on tighteners, hot wires at the top of fences. And this example that we see a lot is somebody will build a 4-foot tall or a 53-inch tall woven wire fence, and then they'll go above that and they'll put a single strand of hot wire. The hot wires would be best utilized at nose level on the animal, whether it's a sheep or a cow, will determine the height, but the hot wire will be better utilized somewhere where the animal is going to stand and rub, not at the top unless you have giraffes. If you have giraffes, then put your barbed wire or your hot wire at the top. If you don't have giraffes, put the hot wire where the animal is actually going to contact it and it's going to do some good. So, and a barbed wire at the top, that's really good for catching deer. So if you want to catch deer and get deer trapped in your fence, then put a couple strands of barbed wire at the top. So that's something to keep in mind. That's a reality. So barbed wire may have its place in a multi-strand fence, but I don't like to see it at the top of a woven wire fence because it's an entrapment area. And definitely don't electrify it, right, Dr. Hayes? Never electrify barbed wire. Yep. Some more examples of things not to do. I mean, really, you think you're going to find, if they did this at the Louisville Zoo, we would have some great newsworthy articles about once a week with animals escaping. So don't do anything that involves any of this. So, got just a few minutes. We'll show you a couple of different options on some things that we may not have time to cover in the field. Dr. Teutsch, do you have some remarks you want to talk about while we're going through this?
Go ahead, Jeremy.
So what time are we leaving here? What time is the break? Okay. 5 minutes, okay. Okay, so there are a lot of situations where you have a permanent fence, where you have a permanent fence that's already existing on a property, whether it's barbed wire or an older woven wire fence, whether it's fixed knot or low carbon woven wire. We'll see some examples of some low carbon woven wire in the field. If those fences are in good repair, there's no need to rip those fences out and install multi-strand high tensile electric just so we can hook into with some type of temporary fence. What can be easily done is to keep that older fence in place and add a single wire of offset to it at nose level on the animal that then does two things. That offset wire keeps those sheep, goats, cattle, horses from pressuring that woven wire. It also gives us an extension cord all the way around the perimeter, if we desire, to hook into with our temporary fence, which is what we're using for managed grazing to change those dynamics, where we're the ones making the decision, not the critters. So we've got an extension cord to hook into the poly products. Examples of offsets, probably the most common example would be something like this. This is a 4 to 6 inch plastic doodad that goes on a post, and it sticks out that far from your existing fence. Not the best idea. Even if you're using something that is a higher quality plastic, you still have a very small level of separation between accident waiting to happen woven wire and hot wire. So I want to get further away than this in most cases. If you are going to use these, at least use some of the better quality plastics. The hardest color to UV stabilize, coincidentally, is yellow. Yellow insulators always turn white after a few years. Once they turn white, the little ears break off of them. Those little ears hold the wire. If the wire is no longer held in by the little ear, where does the wire go? Wherever it wants to. Typically, it's up next to the woven wire or the T-post, and it shorts out. Stay away from the cheapest insulators unless you want the cheapest performance. But for an offset fence, what the preference would be is to get out further away or completely eliminate the reliance on the flexibility of this plastic when I've got a hot wire hanging off of it. Some examples that you'll see on this farm would be some type of a wire cord offset. These are a ring top design. You'll see some pigtail designs out on the farm that'll stick out anywhere from 6.5 inches on up to 15 inches or so. This gets my wire separated away from the existing fence. However, obviously, that cannot be driven into a pipe fence or a T-post. Pipe fencing is very effective, especially for organic situations, but there are some challenges when it comes to insulation. But these have to be driven into a wooden post. The alternative to that, which you can find these examples around this farm. We actually did a fence school here 2 years ago, year and a half ago, on Kentucky State's farm campus. There's an example of fixed knot with a high tensile electric offset on it, and these are the brackets that we used. These actually twist onto the woven wire itself, so this will go on old woven wire, new woven wire, barbed wire, and it gives you a 12-inch separation. These are removable. If you are leasing ground, renting ground, borrowing ground, and you want to improve the fence while you're grazing your animals, then you can install these at about 30 feet minimum. You can go up to 60 feet between these because we're 12 inches away. So I can every 15 or 20 steps, I can twist one of these on the wire. I can install this about as quick as I can walk around the perimeter with a 5-gallon bucket and a screwdriver. And then when the lease is up or it's ready to move my animals to a different farm and I'm no longer at that property, then I can take my screwdriver and a 5-gallon bucket and I can remove this fence and leave the existing fence in the same fashion that I found it, yes. Separation from your woven wire that's flopping around. But yes, you're only about a couple inches from your, well, you never will have your hot wire will never be in contact as long as it's with the insulator. But the main thing I want is with that woven wire, especially older, if it starts flopping around between posts, then I can get it into my hot wire if my hot wire is here. So if I go 12 inches away or 15 inches, I guess in some cases, then that's a lot further away from my accident waiting to happen. And that's what the woven wire would be in an electric fence situation. Also, with underground cable, some very important things to consider. Number one would be one of Dr. Teutsch's great pet peeves is if when you bury your underground cable, put it inside of some type of a barrier, whether it's old scrap PVC from a greenhouse project, black roll water pipe, not a garden hose because the garden hose isn't going to hold up underground, but it does not have to be electrical grade conduit. And so I'm talking about it when I get to a gateway and I'm going underneath to keep my conduction. I want to put this in some type of pipe where it's easily removed and it's also protected from animal traffic or vehicle traffic under the soil. When using coated cables, number one, don't use this. Don't go home and laugh at your neighbor for using this. Go try to help them out. Don't use Romex cable. Don't use stranded copper cable. Guess what happens if you use stranded copper cable? Copper, galvanized, corrosion, electrolysis. Get a cable that is intended for electric fencing. You can get that. You gonna give me the 1 minute mark? Okay, this is it until we go outside. The last thing to remember, underground cable, you can get single insulated and double insulated. Many brands make single and many brands make a double. If it is a single insulated cable, it will not have a inner coating, and this will short out underground if it's in direct contact with the soil fairly quickly. Within probably 5 years, you'll have some shorts occur in this. A lot of companies will make a double insulated. Every company is going to have a little different color inside, but this is made for direct burial. So with that,